Let's now connect the controller to the model. I'm going to show you two versions in this particular video, and then I'm going to show you the first version being the common mistake, which you should really try to avoid, and the second version is the correct version. Okay, let's start with the wrong version, and we'll launch the app to actually see why it is wrong. I'll also show you in the debugger to see step by step why it is wrong, and also show you on the iPad to really illustrate the idea. It's really important for you to not only to know what the correct version should be, and also to know why the common mistake is actually incorrect. Okay, so now first of all, let's go to the multiple under Java, and then go to multiple buttons activity.java. So that's a controller code which we developed partially previously. Okay, so now given that we already got a counter model class that we developed from the previous video, now we're going to try to create instances or instance of the counter. Remember, this is how our GUI looks like. This is the expected behavior that we would like to see. Basically, we're going to start the counter with the initial value being 1 over here, as we saw from the previous developments. So as soon as we start the, let me show you the GUI here. As soon as we start the app, we would like to see the display over here at the bottom to say counter value is 1. And then when we click on the increment button here, we're going to update the display to say the counter value should be now 2. And then click on the increment again, is going to be counter value 3. And now let's say decrements, we should have the counter value from 3 to 2. So, and then decrement again, and then it should be 2 to 1. Okay, and then when we say reset, we're going to reset the counter value back to 1 always. Okay, that's kind of the expected behavior for our app. But we're going to see why the first version, which looks kind of sensible, but why it is incorrect. So it really boils down into the topic about how we can have a global variable in the same class to be shared among methods or among button clicks. Okay, that's something we would like to see. Because we know that in the controller code, each button has been attached with the method that's defined in the controller code, namely these 3 methods over here, 1, 2, and 3. So to really make the app to work, we really have to make sure these 3 methods actually share the same variable, but I'm going to show you a version that looks like okay, but it's actually incorrect. Okay, so now let's say we do the wrong version first. Okay, so now first of all, I'm going to say if I click on the button increment clicked, if I click on the increment button, it's going to trigger the execution of this method here. So now let me just create a counter object. So I'll say counter C is a new counter object which should have the initial value 1, and then I'll say C dot increments. Okay, and for the button decrements over here, I'm going to say something similar. Okay, also because I triggered the execution of this method, so maybe I should just create a new counter object, C new counter, and then I'll talk about briefly scope or visibility of variable in just a moment once I finish this. And then over here, basically the button click, button reset clicked. So that means if I click on the button over here, if I click on reset, that means I want to set the value of the current counter, which may be already reaching its maximum, back to its initial value 1. Okay, so now if I go back to controller here, the easiest way to do this will be I can simply just say, just create a new object. So that will be back to the normal value, initial value, C new counter, like that. Okay, that's what I can have. Okay, so now I would like to talk just very briefly about the scope of variables, and then understanding the scope of variables is going to give you enough ground to understand why this version here is actually incorrect, and then we'll illustrate that in the debugger and iPad. Okay, so now when we talk about the scope of variable, let's see. So this is basically, let me maximize this. So now this multiple buttons activity is actually a Java class, just a normal Java class. It just happens to be used as a controller. And similarly, this counter class is also a Java class, but it just happens that this class is used as a model. Okay, so now if you go back to the controller class, we can see that we have 1, 2, 3, 4, and 5 different methods. Okay, so there are 2 kinds of variables that you can declare in a class, in the Java class. Okay, so one is so-called the local variable, which means, for example, the counter C over here, that we simply just declare under this particular method over here. So that means this particular variable over here called C is only going to be visible within this particular method, which means whatever change that we make in this to this particular local variable here is not going to be effective to other methods. Okay, so let me just illustrate this a little bit more. Okay, let's say if I declare some integer I is assigned to 23, for example. Okay, so this local variable I over here is only visible within this method here. So this is so-called a scope, S-C-O-R. Okay, let me just say, scope of this local variable is button increment clicked method. Okay, so it's a common for you. Okay, that's so-called a scope. So that's some word you have to know what it means. It simply means under what's the range of the code that can actually use this particular variable. Okay, so that means now if I simply just go to another method over here, if I say I is reassigned to 24, okay, however I cannot do that because you can see that the integer I here was declared only under this particular method here. So now in any other method that's completely independent, we simply just cannot, it's simply not visible to other methods. So if you actually want to have a variable that's actually shared among different methods, what should you do? This is what you should do. I'll show you. So now, if you really want to have some kind of like a global variable to be shared among different methods in the same class, this is what you can do. What I can do is I can declare some attribute over here. I can say integer j, and over here, okay, what I would say is I can say scope of this attribute. This is also why sometimes attribute is also called class variables, which means its scope is within the same class, the whole entire class among different methods. Scope of these attributes is among all methods in this class, which is multiple buttons activity. Okay, so now, for example, I can actually refer to j over here in any of the methods. I can say j is now assigned to 25. Okay, so this compiles, and also I can go to another method over here and I can say j is assigned to 26. Okay, so this is only just an illustration about the two kinds of variables typically in a class. It can be either local to a single method, in which case just like this, like an I over here. Okay, so this variable here was declared just inside this particular method, so it cannot be used outside this method. The other kind of variable is so-called attributes or class variable. The scope of such kind of variables is actually within the same class among different methods, in which case I can use j in different methods over here. Okay, so these are the two kinds. So the first version I'm going to show you for connecting the model to the controller is actually making the mistake of having the counter being local to individual methods rather than being global. Okay, so now before I go on, let me just comment out the I and j. Okay, so these are only for illustrating the idea about scope, but I'll just comment them out, but you can comment them back to try. Okay, try different things. Okay, so now what I would do is I would say now for the first version over here, you can see that counter C over here, they just happen to have the same name. Okay, so C over here is only within the scope of this particular method. Okay, so this counter C over here, even though it has the same name C, but don't get too confused, because over here you can see that the reason that we can redeclare the same name over here is because there's no confusion here, because you're trying to declare this counter C over here. So that means this C here is only within the scope of this particular method, and it has nothing to do with this counter C over here. They're completely separate, which is something I will show you. So at the runtime, when we try to do button clicks over here, either click on the button and execute this method, or execute this, or execute that. So they are actually somehow going to create different objects at the runtime. Okay, that's something we'll see. Okay, so now having said this much of background, let's try to launch the app and then to see if the why the app is going to behave wrongly. Okay, So in your case, if you're using your virtual machine or you're using a lab machine, you can actually connect your tablets using a USB cable. In my case, I'm just going to run some virtual device, which will also illustrate the point. Okay, so now let me just go to run. Let me just go back to project over here, and then I can. I'm still the execution over here is still from the previous tester. So what I can do is I can right click on the controller file, and then I can say run the activity file, which will launch the app. And over here, I already added a virtual device over here, just next ASUS Nexus 7. Which is what we have in the lab. Okay, doesn't matter. You can just add any device you like, or just connect some physical device. Okay, if I say OK over here, it's now going to launch the app over here on the tablets. Let's see why the behavior is actually wrong. Okay, so it's going to launch. You can see we got 3 buttons over here. Oh, one more thing to do. Okay, I forgot. Okay, so now you can see that over here, for each of the 3 buttons here, after I do the increment, decrement, or reset, I'm actually going to actually, so okay, over here, C dot decrement over here, forgot to say that. So now, after that, I want to display some outputs to the mobile screen. What I should do is I'm going to call this particular helper method to do it. Okay, what I can say is I can say set contents of text view, and then r.id dot. So I'm going to use the okay, I can just go back here and look it up. So if I go back to GUI over here, and now this is my text view, and ID is label result. Okay, let's do it. Let's go back here, and then I can say label result, and then the content will simply be c.to string. Okay, so now similarly, I'm just going to copy this line here, and then paste it for the other 2 methods over here. Okay, let's relaunch the app and see the effects, and to see why this first version over here, where the counter values are simply just local to each method, why it is wrong. Okay, let's click on this play button here, and then you will launch again the tablets. Okay, let's just wait for that to come over here. Okay, so now I'm gonna say, remember initially, there's one more thing I can do before I launch the app. If I want to display something when I first launch the app, what I can do is there's something we haven't seen so far. Pay attention to this particular method here called onCreates. In the previous tutorial, we didn't actually touch this method. You can actually expand this method a little bit to say, when we first launch the app, what are we going to do? You can see somehow these 2 lines by default simply tells you that whatever you actually define as your GUI is going to be loaded to the mobile screen, when you first launch the app. So we can say once you launch the app, we would like to display the contents of the counter initially. Okay, so what we can do is we can simply go to over here. Let me just copy this line again, and we're gonna paste it over here. So do not delete these 2 lines, leave them as is. Okay, we're gonna say that once you load the GUI, we're going to do this. Okay, but now you can see the trouble is, so here if I have counter C is assigned to new counter, right? But somehow you can see, as I said before, the C over here is only visible within this particular method over here. It's not visible outside this method. And in this method here, we simply didn't declare any counter. Okay, so the best we could do is something like this. Counter C is assigned to new counter over here, and then like that. Okay, now it'll be visible. Okay, so now let's try. Again, this first version here, hopefully you already get a sense why it could be wrong. Because we are, at the runtime, we are simply just going to create more than 1 counter objects. And it's not really just a single shared object that's going to be manipulated by our app. Okay, let's now just click on play. And then we'll just go here and wait for the app to be loaded. You can see that over here on the on this answer label over here, you simply say initially, which is resulted from this line over here. You simply say the counter value is 1. Okay, now let's say we want to click on this increment button here. What do we expect to see? We should really expect to see after this, counter value should be incremented from 1 to 2. Let's see if that's really the case. Okay, I'm going to click on this. Its value is 2. Okay, this time is okay. However, let me do it once more. Okay, if I click on increment another time, I should really expect to see from 2 to 1. Okay, and if I click on increment, counter value is 2. Okay, it doesn't really change from 2 to 3. And now if I click again, counter value is 2. Click again, counter value is 2. Click again, counter value is 2. So it stays in 2 always. Okay, we'll see why this is happening in just a moment. Okay, what about decrements? What do we expect to see? Current value is 2. If I click on decrement, it should really go from 2 to 1. But is it really going to be the case? Now, decrement. It actually goes from 2 to 0. Okay, and then if we say decrement again, it should really decrement 1 more, right? However, if we say decrement, counter value is 0. Decrement again, counter value is 0. You can see that somehow the behavior is simply just wrong. It doesn't really just increment by 1 for every button click on the increment button. It also does not decrement the value of the counter for every button click of the decrement button either. And then if we say reset, it seems to be okay. So we got 1 here, but you can see collectively just doesn't really work well. So this is simply a wrong version. Okay, we know, first of all, we should know that this is wrong. But now we want to understand why this is wrong. Okay, before I show you the debugger, which is the best way to really convince you how the machine is running, I want to show you quickly on the iPad to get an idea how things are actually being running. Okay, let me just go to the iPad. So this is the wrong version over here. I'm just going to illustrate to you why it is wrong. Okay, so now we are in the context of the multiple button activity class. Okay, so we got the 3 methods over here. We got button increment clicked, we got button decrement clicked, we also got button reset clicked, and we also have the onCreate method over there. Okay, I just didn't have space to put it down, but you can imagine that we also got these this onCreate method there, where we also try to create a new object of counter. The illustration is going to be ignore this part, but you can certainly also reason about it yourself. Okay, let's see what's going to happen here. Okay, so now imagine this. When we, let me go back to the GUI over here, and then, okay, when we click on the increments, what does that mean? When we click on that, it's going to trigger this part of code to be executed. And now you can see this part of code to be executed over here, which is this method here, right? And then this is going to execute this line of code. As we talked about before, this line of code where it involves the new keyword, which means we're going to create a new object in the memory for counter, and then we're going to store the address of this new object here in C. Okay, let's see what it is it's going to do. What this will do is, so it's going to have a variable C, and then it's going to point to some objects conceptually of type counter. And then we know that every counter has only a single attribute called value. Okay, and then we know that the initial value for the counter should be just 1. Okay, just 1 over here. Okay, and then we go to the second line over here. We say c.increments. When we say c.increments, we're going to execute the increment method, which we saw before. If you go to the counter class, you can see increments over here. It's going to say this.value plus plus. And because the context object right now is C, so that means this over here is going to be substituted by C. That means C.value plus plus. Okay, that means we're going to increment this value. C.value is here, increment plus plus, then we go from 1 to 2. Agree? Okay, so now let's say we try to click on the same button again. Okay, let's see what's going to happen. Okay, so the red one I just annotated was only the first time that I click on the button. Okay, let's imagine that. Let's go back to our emulator over here. Let's say I try to click on this increment button again. Since I just went, since the value just went from 1 to 2, I should really expect the value to go from 2 to 3. However, it's not the case, because now, if I click on the button again, I'm just going to execute the same block of code over here. Exactly the same. Okay? What it will do, I'm going to use a different color to show you. Let's say this time I'm going to use maybe maybe green, maybe pink over here. Okay, let's say this time I'm going to execute the same method for the second time. Okay, for the second time, I'm also going to execute this same line of code over here for the second time, which is going to create just a separate counter object. That means C, another counter object, which is has the same name, and then C is going to point to just another counter object, separate object, completely independent. And then it's going to be of type counter. And then we're going to have the value attributes over here with the initial value 1, because over here right now, when we reach the second line over here, the context object again is the C over here. And then when we say increments over here, it's going to say C dot value over here is incremented from 1 to 2. That is why previously, whenever I try to, let me go back to emulator over here, whenever I try to actually say increment, and then it will always give me counter value is 2. It doesn't matter how many times I click on that, because every time I click on that, it's simply just going to execute this block of code. Okay, the same. Okay, just the same. Okay, so every time I execute this block of code, it's simply just going to create a new object, separate object from the previous click. And then the counter value will just be initially 1 and incremented to 2. Okay, so there is no accumulation effects taking place. Okay, that's the main point. Okay, similarly, the first time when we click on button decrement clicked, what happened was, so let me just illustrate that also very quickly. Now, let's say over here, the first time when I click on decrements over here, it simply says counter value is 0. So why is that the case? Okay, so now when I click on button decrements clicked the first time, again, it's going to execute this line over here, and then so there will be a separate object C of type counter. Okay, it's going to be pointing to some counter objects, and then with value being initially just 1, because now 1, and then when we reach the second line over here, we say C dot decrement, so the context object here over here is C, as we recall. So if you go to counter class over here, decrement is simply going to be this dot value minus minus, and now the context object is actually C, which is over here, right? So this is the context object over here, and when we call the increment, it's going to say C dot value over here minus minus, so that will go from 1 to 0. Okay, so now if we try to click on this particular decrement button again over here, let me just go back there, emulator. So now if I click on this again, currently it's 0. I would have expected to go from 0 to -1 if I try to click this one more time. However, click on that, it doesn't go to -1. It simply just stay on 0. Why? The same idea. Okay, so that means if I try to, let me use pink this time. Okay, so now when I try to click on this button the second time, I'm still going to execute the same line of code over here, which is just going to create just another counter object. In this case, it also be called C. Okay, so somehow the Java compiler can tell this, even though they have the same name superficially, but they have a way to tell. Okay, now you have C over here. It's also going to point to some counter object over here. Okay, counter, and then with the initial value being 1. And then when you reach the second line for the same block of code, now the context object is now this C over here. And then when you say decrement over here, you're going to have C dot value, and the C is a context object. So C dot value is over here. So when you say decrement, it's going to go from 1 to 0. That is why every time when you click on the decrement over here, it's always going to be counter value is 0. Okay, so what we have seen so far basically on the iPad is if you simply make the counter objects local to the methods like this. So this is the main issue. You can see counter C over here, counter C over here, and similarly counter C over here. So the declarations of your counter objects or your model objects within each individual method is going to make them simply just local, which means every time when you click on the button, it's just going to create a fresh object. that means there's no way for you to accumulate the increment or decrement effects to the same shared objects. Okay, so that's really the problem, because we want exactly the opposite. Okay, so now let me just show you one more thing very quickly. Okay, I just want to show you something that you can also try in the debugger. Okay, so now you can see that I want to illustrate the following to you. Let's say I will try to click on this particular method over here, button increment clicked. I want to click it for twice. I want to illustrate to you that it is going to create two separate counter objects, which means they are not the same. That's something I would like to illustrate to you very quickly. How do I see? So basically you can see that C and C here, since they refer to different counter objects, that means these two counter objects should reside on different locations in the memory. What does that mean? That means the addresses should be different. But how do I see that addresses are different? There's something I would like to show you very quickly. Okay, so now let me just go back to my controller code over here. What I would like to do is, let's say button increment clicked. Okay, what I would do is I will simply put a breakpoint over here. Okay, just here, right before I try to create the new objects. Okay, I'm going to execute the same block of code twice by clicking on the same button twice. I want to illustrate to you, every time when I try to execute the same block of code, it's simply just going to create a different, brand new counter objects. Okay, so that will simply just correspond to the diagram I'm trying to show you here. A different object the first time, and also another different object for the second time. Okay, I want to show you very quickly. Okay, so once I put a breakpoint over here, so now we are basically running controller code before we show you the debugger when you try to run the tester. Okay, now we'll try to show you you can also run the debugger by launching your app. That's also very easy to do. That's also a very useful technique for you to acquire. Okay, so now once I put the breakpoint over here, what I will do is I'm going to actually put, rather than clicking on display over here, I'm going to go to the debug button over here. It will say debug multiple button activity. Okay, I will choose that one there, and then I'll just say I want to restart the app. Okay, and now I want to use the same tablets over here. Let's try that. Okay, so now the same user interface has been brought up, but now we are running in the debugging mode. Okay, initially the counter value is 1, and then as soon as we hit on this button here, it's going to trigger the execution of this block of code. And because we put a breakpoint over here, it's going to pause over there right before we create a counter object. So we're going to see what the address is. Okay, so now go back to the emulator. So now let's click on increments. Okay, if I click on that, you can see that we pause right before we create these counter objects. Okay, so now I will simply just say step over, because we did in previously how you can step into the constructor and see how the object is created. We have seen that in the previous video. So now we'll simply say step over here. So now you can see that the object with the name C over here has been created. Okay, how do we see its address? It's exactly over here. You can see that counter at 5459. So as I explained before, so the address is more like the address for the sequence in your binary sequence of bytes memory. But in the compiler, it doesn't show you that complete information. It's like a so-called pseudo address. That'll be good enough to get you some idea. So basically just a unique address for every object that every time you create. Okay, for this particular object creation that we just executed, it has created an object of address counter at 5459, and it has been stored in this particular C, and this C is the very first execution of this method here. Okay, so now let's just write this down in the iPad as a note. So counter at 5459. So over here the address is counter at 5459. Okay, so that's the first call to this particular method over here. Okay, so now what we like to show you is, let's try to finish this particular method call and then go back to the GUI of the phone, of the tablets, and then we're going to show you that after the second click, of the same button, and after the execution of the same block of code for the second time, we're gonna get something that's completely different, like namely a new counter object with different address. That's something I would like to show you very quickly. Okay, so now we are done with this. What we can do is we can say we simply just want to exit from the current method. We can say step out. Okay, we'll step out, and then step out, step out, step out. Just many other things you don't have to worry. Just keep stepping out until you cannot do any further. Okay, so now you can see that everything's disabled. That means we are now, if you switch back to the your tablets over here, you can see that we can click again. Okay, let's click on the increment button for the second time. If you click on that, you will see that now we are executing the same block of code for the second time, which is like the pink one, which I illustrated before. Okay, so now we're gonna step over here and see that over here you can see that we just got another counter object created, and the address is something that's different. The absolute value for this address here is not important. What's really important is you can see it's a different address, meaning that it's a different object that's being created over here. Okay, let's write it down. Counter at 5534. So over here is counter at 5534. So these are completely different addresses. Okay, so that really illustrates the point. You can try to use a debugger and try to see that when you try to click on the decrement button for two times, the first time and the second time are actually going to create two counter objects with different addresses because they're simply different objects. Okay, so this is basically the insight into the first version of the solution that's actually incorrect. Okay, so now we're going to show you how you can do a correct solution for the second version very quickly, and that will illustrate on the iPad and illustrate very quickly on the debugger. Okay, so that will make a complete story about the two versions. Okay, so you should really study these two versions very carefully and make sure you use the second version for this particular kind of app where you want to have shared objects. Okay, so now what I will do is I'm just going to show you how what you should change for your code. As we said before, if you want to have a variable that can be used by all the methods, what you can do is you can declare that outside all the method, make it an attribute. What we will do is we're going to declare counter C over here instead. Okay, so now what you will see is what we will do is we want to make sure this C object here is shared by all the other methods, which means you will try to avoid to redeclare this particular object and make sure it's always this particular object. Okay, so counter C over here. So now there's several places we have to change. First of all, we want to make sure on create, we're simply going to say we don't redeclare the same object variable. We simply say C is assigned to a new object. So we only there'll be only two places where we are trying to create a new object. When we try to first launch the app, we'll simply just create a counter object, just a new one, brand new, and then store its address in C, and that's the only time before the next reset. Okay, and then when we go to this method here, so we don't have this redecoration anymore. We simply say C. You can see that the code still compiles. Why? Because this C over here is referring to this C over here. You can see that somehow the Android Studio is giving you some hints. Let me just remove this debug button just for now. You can see that if I move my mouse over, you can see this one is actually pink, right? And then it's actually referring to this purple one that has been declared in the at the class level. Okay. Similarly, I'm also going to delete this. And also I'm going to delete this. You can see that the crucial difference is right now, actually, to be more precise, I do not even need this thing over here. Okay, let me just undo what I just did. So I think this will be more informative to you. Okay, basically what I want to do is I only try to create a new object on create when I first launch the app, and then over here I can simply comment out this line of code over here, which means I can say based on the C object that has been updated so far, I'm going to further increment it. Okay, I'm simply just use C over here, and C is referring to this counter object at the class level. Okay, so now having this line here is going to give you the mistake that we have observed from version 1, because this line here is simply just going to create a new object and then change its address stored in C. Okay, that's something we want to avoid from the first version. Similarly, we're going to just comment this out. Okay, and then we just say C.decrement. So this C over here again is referring to this counter C that's declared at the class level. Okay, and then finally we're gonna say this is the second place where we're going to have. Okay, let me say this is let me just say first run version over here. What we'll do is we'll say C is assigned to new counter. As an exercise for you, instead what you can do is you can say C.reset. Okay, so that means you have to go back to your model of the counter class over here, and then you can just define another mutated method here, maybe call it reset, and then you can simply reset the counter value back to 1. Okay, I'll leave that as an exercise for you. That's an alternative. Okay, rather than just creating a new object. Okay, both will work. Okay, let me go back here. And then you can see that we simply just say, now we're going to create a new object, brand new object with different address. And then we're going to store the new objects in C after reset. That means any subsequent increments and decrements are going to have the effects on the new counter objects. Okay? Okay, that's the change you have to make. Let me just recap very quickly the changes you have to make. And then we'll see that launch the app, make sure it works, and then I'll show you it on the iPad and show you on the debugger. Okay, that's how we finish this video. Okay, so now we declare this class level counter object over here, and then we don't redeclare this counter object anymore in all the methods. So there are only two places where we are trying to create a new object. The first place is on creates, which means we simply try to create a new object for the first time and store its address in this global variable C. And then the second place is when we try to reset. That means we just create a fresh object with some initial fresh value, and then we store that address in the same variable C, just different objects, different address. And then for any of the two, button increments and also button decrements, we do not try to do what we did in the first version, which was wrong. We did not try to create any new objects counter. We simply just use the same C over here to accumulate the effect to the counter value. Okay, that's kind of the what we have done. Of course, this is basically just a pattern for you to actually have a shared object at the class level over here, and any button click over here is going to somehow modify the states of the objects. Okay, it can be increments or it can be decrements. The key thing is you do not try to recreate any objects. Okay, you do not try to do it. You simply just call some mutator methods directly. Okay, and also access a method to reflect the latest state, of course. Okay, so now let's launch the app again and see if this is really working. Okay, let's launch the app, and then we will see that it's that's really working. And then I'll show you briefly on the iPad and the debugger. Okay, let's now go back to our emulator. Initially, counter value is 1. Now increment once to 2. Increment another time to 3, increment another time to 4, increment another time to 5. Okay, it seems to be working. And now when we say decrement, decrement once to 4, decrement to 3, decrement to 2, decrement to 1, decrement to 0, decrement to -1. Okay, let me just show you one more thing that you can do. Okay, we can make the app a little bit more robust to say there is actually a maximum and also minimum for the counter value. We want to say we will only try to increment when we have not reached the maximum just yet. Okay, what we can say is if C dot, remember we declare some, we define some accessor method called has reached maximum over here. So it's a Boolean value. Okay, it's a Boolean method, which means this method call over here is going to return either true or false. If we have already reached the maximum, what we will do is this. Let me just copy this line here, and then I'll show you what I want to do. We can go to the same label result, and then we'll simply print out something like error. Counter already reaches its maximum. Okay? Otherwise, what does that mean? That means it is not the case that we have reached the maximum. Implicitly, else means the negation of the if condition. Otherwise, that means C dot has reach maximum is actually false, in which case we can increment. Okay, let's try. And then I'll leave the exercise for you to actually expand the decrement method in a symmetric way. Okay, so now let's go to the app again. Let's relaunch and then see. Remember the maximum for the counter was, let's just review ourselves very quickly. The maximum is actually 3. So we can only increment from 1 to 2, 2 to 3, and then we cannot go anymore. Okay, so now let's go back to our emulator here. So increment 1 to 2, increment 2 to 3. Now, if you do increment again, it's going to say error, counter already reaches its maximum. So we cannot increment anymore. Doesn't matter how many times we do increment. Now, what we do is we can say decrements, and then now go from 3 to 2, and then 2 to 1. Now we can keep incrementing again until we cannot do it anymore. Okay, so you get the idea. Okay, so now the app is now really working. One more thing to show you. When we say reset over here, and then reset is going to remember actually to create a new object over here in the new object over here, and then create a new counter object with initial value 1 and store the new different address of the objects into C, right? That's what we did. Okay, and then that's why we just go back to counter value is 1, and then we can keep incrementing and decrementing accordingly. Okay, now I want to show you very conceptually how this works on iPad, and then we'll see that on the debugger very quickly. Okay, let me stop this over here, and then let's go to iPad. Okay, now in the correct version over here, the key is onCreate. So this is really important over here. When we got onCreate, the method over here, when we first call that, when we first launch the app, this onCreate is going to be executed, and we are just going to create call this particular execute this particular line. What this will do is it's going to do the following. Okay, let me just use this. It's going to say C, a variable is going to point to some objects over here of type counter, initially with the value of 1. Okay, so now imagine that if we, I kind of lost the GUI already, but now if we click on the button for increments over here, it's going to execute this block of code. And now notice that we're in this block of code, we are not trying to create any new counter objects. What we are trying to do is we simply say, because this C over here is really referring to this C over here. Okay, it's referring to the same C, which is here. So now when we say C.increments, remember it's going to be C.increments. The definition is counter over here. C.increments is going to be this value plus plus. Okay, so that means the C over here is really the C over here. C.value plus plus is going to go from 1 to 2. And then if we try to click on the same button for the second time, it's going to execute the same line of code without creating any new counter objects. In this case, C over here again is referring to the same C over here, like here. Okay, and then C.value is the same value over here, that plus plus, and then we're going to say 2 to 3. Okay, you kind of get the idea. Similarly, if you try to click on the decrement button over here, it's also going to refer to the same C over here, the same. You might be wondering what happens if we try to say reset. Okay, what's going to happen is as follows. If we say reset, what we'll do is we'll try to execute this line of code, and the C over here is again referring to the same C over here, the same. However, what we'll do is we'll first of all create a new object over here of type counter. Okay, when we say reset, and the value is going to be 1. Okay, now we're going to say that C over here, the same variable, is going to store the address of this new object over here. So that means it's going to point to here instead. It's not going to point to the old object. That's what when we say reset. Okay, that's actually the conceptual mapping you should really have to see how this second version is working, which is correct. Okay, let's now have a final look on the debugger very quickly. Okay, and then we are done with this video. So you should really study these two versions very carefully, and then it's going to benefit you very well for the later lab exercises. Okay, so what we'll do is we're going to have go to the activity file, Java class over here. What I will do is, first of all, I'll put the breakpoint over here, okay, on the onCreate over here, and then I will also put a breakpoint for the increments. Okay, that's what I will do. Okay, and then I want to show you that, first of all, we're going to create a new object with the address, and then I'll show you that when we click on the increment, it's going to be dealing with the same increments, the same counter object. That's what I would like to show you. Okay, so now we got two breakpoints, one in the onCreates and the other one on the button increment clicked. Okay, so now let's launch the debugger again. Okay, now I'll launch it and then I'll show you. Okay, now we are at the point right before that we are trying to execute this line. So now we actually got C variable over here, but it has not been storing any meaningful address just yet, but it will. So now simply means no address stored just yet. Okay, so now after we do this, let's say step over, let's see what's going to happen. If we say step over, we do have some address over here. Let's copy that down. It's counter at 5390. Okay, for the very first time. Okay, so now for the very first time, okay, like the red over here, right? It's before we do the reset. Okay, so now over here is counter at, okay, let me just remind myself, is counter at 5390. 5390. Okay, so now I'm going to show you that we're going to click on the button increment click over here. We're going to click on the button increments, and then this block of code will be executed. I'll show you that this context object over here is going to have the same address as this one. That's something I would like to show you. Okay, that means the object is really shared among the methods. That's something I would like to show you. Okay, now how do we do? Let's step out first. Step out a few times until you cannot step out any further. That means we go back to the GUI. Okay. Okay, now we are back to the GUI over here. So now I would like to do increments over here. As soon as you click on increments, now we are here, right? So now I would like you to pay attention to the C over here. You can see that C is here. What's the address? Counter at 5390. Okay, now counter at 5390, the same address. Oh, okay, the same address as before. The same as before. Just the same. 5390. Counter at 5390. Okay, let me just illustrate even more. Okay, what about decrements? I also put decrement here. That's step out, step out, step out, step out, step out. Okay, now back to the GUI over here. Let's now back to the emulator over here. Let's say decrements. I say decrement over here. Now also the C. What's that? Counter at 5390. Counter at 5390. That means doesn't matter how many times I click on this button here, and doesn't matter how many times I click on this button here, before I do a reset, all the button clicks are going to modify or access the same counter object that's being shared. That's a critical point you really have to understand. Okay, now final illustration. What if I click on reset? What's going to happen? Okay, what I will do is I will also put a breakpoint over here on here. Okay, let's step out first. Okay, keep stepping out until we see gray out. Okay, let's go back to emulator over here. As soon as I say reset, so now we are here. Okay, now you can see at the moment is 5390, just as before, the red one. Okay, we're gonna see that as we said before, the illustration before, once I try to execute this line over here, we're going to create a new object over here and then store its different address in the same variable C. Okay, we're gonna see that exactly. Okay, it's at the moment it's 5390 right before we click execute this line. I'm gonna say step over, and then you can see that what do we have now? After this we got 5651. Okay, now we got over here. Okay, so that means it's not going to point to this address anymore. It's actually going to point to 5651. Okay, counter at 5651, I believe, right? 5651. Okay, let me do a little bit further for a complete story. Okay, now what's gonna happen if I do a subsequent increments? Is it gonna be 5390 or 5651? That's the question. Okay, the answer should be 5651 because now counter C is now already pointing to a new object that we just created after reset. Okay, let's do a final illustration. Okay, step out, step out, step out, step out. Okay, now let's go back to the emulator. And now when we say increments over here, now we're back here. And now we also got a C over here. What's the address of C? 5651. 5651, which is this new address over here. Okay, what about decrements? Okay, step out, step out, step out. Okay, now go back to emulator over here, and then let's go for decrement instead. So now what's C? C's address? 5651. Okay, you can see again it's 5651. Okay, hopefully you can see that the way we try to explain version 2 to you. Basically, the same object has been created in the very beginning for the onCreates over here. Okay, onCreate. And then for all the subsequents, doesn't matter how many times of increments and decrements over here, increments and decrements, all the reference to the variable C over here is referring to the same object as we have seen on the iPad and also on Debugger for the same address. And after the next reset, is going to reset the C to store a new object of different address as we have seen. Okay, so that's really the key. The key is we actually declare a counter over here at the class level rather than at the individual method level. Okay, so you really want to rewatch this video for as many times as necessary to really make sure you understand totally the two versions, especially the first version, multiple counter objects without any sharing, which is not correct for our particular purpose of the app. And the second version there, we have a single counter object whose state is actually shared by among multiple methods, which means every time you click on the same click on the same or different buttons, it's actually going to modify the same objects. Okay, study these two versions very carefully.